A gear is a rotating circular machine part, having cut teeth, which mesh with another toothed part to transmit torque. Geared devices can change the speed, torque, and direction of a power source. Gears are used to transfer motion and torque between machine components in mechanical devices. Gears of different sizes produce a change in torque, creating a mechanical advantage through their gear ratio. It is necessary to accurately understand the differences among gear types to accomplish necessary force transmission in mechanical designs. So in this video, we'll look into different types of gears that are used in various machine parts and industries. Spur gear. Spur gears are the simplest type of gear. They consist of a cylinder or disc with teeth projecting radially. Though the teeth are not straight-sided, the edge of each tooth is straight and aligned parallel to the axis of rotation. These gears mesh together correctly, only if fitted to parallel shafts. Spur gears are excellent at moderate speeds, but tend to be noisy at high speeds. This is different than helical gears, which have more than one tooth in contact and transmit torque more smoothly. Helical gear. Helical gears are used with parallel shafts, similar to spur gears, and are cylindrical gears with winding tooth lines. They have better teeth meshing than spur gears and have superior quietness, and can transmit higher loads, making them suitable for high-speed applications. Helical gears come with right hand and left hand twist, requiring opposite hand gears for a meshing pair. Double helical gear. Double helical gears are a variation of helical gears, in which two helical faces are placed next to each other, with a gap separating them. Each face has identical but opposite helix angles. Employing a double helical set of gears eliminates thrust loads and provides smoother operation. Double helical gears are commonly used in enclosed gear drives. Herringbone gear. Herringbone gears are very similar to the double helical gear, but they do not have a gap separating the two helical faces. Herringbone gears are typically smaller than the comparable double helical, and are ideally suited for high shock and vibration applications. Herringbone gearing is not used very often, due to their manufacturing difficulties and high cost. Here is a quick question. Spur gears can be used only when the two shafts are parallel. Is it true or false? Tell me in the comments. Bevel gear. Bevel gears have a cone-shaped appearance and are used to transmit force between two shafts which intersect at one point. A bevel gear has a cone as its pitch surface, and its teeth are cut along the cone. One of the most common uses for bevel gears is for changing the power transmission axis. This makes the operation smooth and quiet. Spiral bevel gear. Spiral bevel gears are bevel gears with curved tooth lines. Due to higher tooth contact ratio, they are superior to straight bevel gears in efficiency, strength, vibration, and noise. They are more difficult to produce. Also, because the teeth are curved, they cause thrust forces in the axial direction. Miter gear. Miter gears are bevel gears with a speed ratio of 1. An engaging pair will always have the same number of teeth. They transmit power between intersecting axes. Miter gears are used in machines to change the direction of rotation only. They do not cause a change in the shaft speed or torque. There are straight miter and spiral miter gears. Straight miter gears offer the advantage of not having to deal with any axial thrust. But they come with the limitations of straight bevel gears. Spiral miter gears produce axial thrust, necessitating the need for thrust bearings. Worm gear. Worm gears transmit power through right angles on non-intersecting shafts. Worm gears produce thrust load and are good for high shock load applications, but offer very low efficiency in comparison to the other gears. Due to this low efficiency, they are often used in lower horsepower applications. A unique characteristic of this gear drive is that the gear pair rotation can be locked. This is because the worm wheel cannot turn the worm gear if it is set at a certain angle. However, the worm gear can turn the worm wheel at any angle. This property is utilized in applications that require self-locking mechanisms. Worm gears come with certain disadvantages, that the transmission efficiency is not as good compared to other gears. Also, the fact that sliding occurs between the worm and worm wheel during transmission makes lubrication a factor for smooth operation. Hypoid gear. Hypoid gear resembles a spiral bevel gear, but there are some marked differences. Unlike spiral gears, hypoid gear shafts do not intersect. These gears is placed offset to the crown wheel, which is usually a spiral bevel gear. They achieve higher speed reduction due to their large contact ratio. The increased contact also permits higher load transmission while suppressing noise and vibration. Here is a quick question. Which of the following can be used for power transmission in intersecting shafts? Is it spur gear or bevel gear? Tell me in the comments. Gear rack. It is possible to combine spur gears with a rack to convert rotational motion to linear motion. A rack consists of teeth cut in a straight row on a flat surface. These teeth have the same profile as the spur gear. The spur gear teeth mate with the teeth on the rack, similar to how they would mesh with another spur gear. When the gear rotates, it pushes the rack in a straight line. The gear rack system are used in many products, such as automobiles, stairlifts, and railways. Crown gears. Crown gears are a particular form of bevel gear, whose teeth project at right angles to the plane of the wheel. In their orientation, the teeth resemble the points on a crown. A crown gear can only mesh accurately with another bevel gear, although crown gears are sometimes seen meshing with spur gears. A typical use being a crown gear and pinion system, which allows a rotary motion to be shifted at 90 degrees. Screw gear. Screw gears are a pair of same-hand helical gears with the twist angle of 45 degrees on non-parallel and non-intersecting shafts. The tooth contact is a point, their load carrying capacity is low, and they are not suitable for large power transmission. Internal gear. Internal gears have teeth cut on the inside of cylinders or cones and are paired with external gears. The main use of internal gears are for planetary gear drives and gear-type shaft couplings. The rotational directions of the internal and external gears in mesh are the same, while they are opposite when two external gears are in mesh. Rack and pinion gearing. A rack is a toothed bar or rod that can be thought of as a sector gear with an infinitely large radius of curvature. Torque can be converted to linear force by meshing a rack with a round gear called a pinion. The pinion turns while the rack moves in a straight line. Such a mechanism is used in automobiles to convert the rotation of the steering wheel into the left-to-right motion of the tie rod. Here is a quick question. The gear used to convert rotary motion into translating motion is it rack and pinion or worm and wheel? Tell me in the comments. Epicyclic gear. In epicyclic gearing, one or more of the gear axes moves. Examples of this type of gear are sun and planet gearing. Sun and planet gearing is a method of converting reciprocating motion into rotary motion that was used in steam engines. In this image, the sun is yellow, the planet red, the reciprocating arm is blue, the flywheel is green, and the drive shaft is gray. Harmonic gear. A harmonic gear, or strain wave gear, is a specialized gearing mechanism, often used in industrial motion control, robotics, and aerospace. For its advantages over traditional gearing systems, including lack of backlash, compactness, and high gear ratios. Cycloid gear. The cycloid gear profile is a form of toothed gear, used in mechanical clocks, rather than the involute gear form used for most other gears. The gear tooth profile is based on the epicycloid and hypocycloid curves, which are the curves generated by a circle, rolling around the outside and inside of another circle respectively. A limitation of this gear is that it works for a constant distance between centers of two gears. This condition in most of the cases is impractical, because of involvement of vibration, and hence in most of the cases, an involute profile of the gear is used. Cage gear. A cage gear, also called a lantern gear, or lantern pinion, has cylindrical rods for teeth, parallel to the axle, and arranged in a circle around it, much as the bars on a round bird cage or lantern. The assembly is held together by discs at each end, into which the tooth rods and axle are set. Cage gears are more efficient than solid pinions, and dirt can fall through the rods, rather than becoming trapped and increasing wear. They can be constructed with very simple tools, as the teeth are not formed by cutting or milling, but rather by drilling holes and inserting rods. These gears are sometimes used in clocks. The cage gear should always be driven by a gear wheel, that not used as the driver. Magnetic gear. All cogs of each gear component of magnetic gears act as a constant magnet, with periodic alternation of opposite magnetic poles on mating surfaces. Gear components are mounted with a backlash capability, similar to other mechanical gearings. Although they cannot exert as much force as a traditional gear, due to limits on magnetic field strength, such gears work without touching, and so are immune to wear. They have very low noise and no power losses from friction, and can slip without damage, making them very reliable. They can be used in configurations that are not possible for gears that must be physically touching, and can operate with a non-metallic barrier, completely separating the driving force from the load. The heart of a gear drive is obviously the gears within it. Gears operate in pairs, engaging one another to transmit power. As you see, there are so many different types of gears are used in various applications. If you have still think I've missed any of the gears, let me know in the comments. Like this video if you found it useful, share it with your friends, and subscribe to the channel for more related content. Also, watch this video if you want to know more about gearbox and types of gearbox used in automobiles.